Hi, today we're going to go over the build of an Eggtimer mini switch. This is the smaller version of the full-size Wi-Fi switch that Eggtimer sells. And it has virtually all the same functions. It's exactly the same switch. It just doesn't have the continuity checking that the full-size switch has. I think that actually makes this a better switch in so many ways. It's simple, it's easy, it's smaller footprint, and it works just very simply. It turns your device on and off. So this really is my go-to Wi-Fi switch now, but from Eggtimer. This is my setup. I use a Hakko FM203 station, and I use a 0.3 millimeter tip iron with my own Kester soldering wire, a vent fan, vices, silicon mat. I don't think you need anything this sophisticated for this build, but do be aware that this build has a lot of very, very small parts. The resistors in particular are incredibly small, so I'm not sure one of the cheap like 15-watt irons is really going to cut it on this one. So you may want to think about upgrading if you're going to be doing these smaller builds a lot. So go ahead and open up the package that you get from Eggtimer and pull everything out. We're going to lay it out on the mat and then do a inventory via the checklist. And as always, I recommend you do an actual inventory and check off every part on the list physically so that you know you have it, and also so you recognize the parts themselves as you're going through the build. So remove everything from the anti-static bag. And then, as you'll see here, I like to cut out that Wi-Fi pass key and put it aside because you're going to need it later. And then I usually put my builds right back into an anti-static bag when I'm done to store them. And I put that piece of paper right in the bag with there so I know I don't lose it. Okay, so here's all the parts, and we're going to do the inventory. The checklist comes with it, and you're going to actually want to check them off as you go. We're doing the Rev A7 version of this mini switch, so make sure you're following on with the right build here. And as we go through here, the first thing up is the circuit board. This is where this is the PCB that you're gonna solder all the parts to. Next up, you've got a Wi-Fi module, and then after that, you have a 3.3 volt voltage regulator. These are pretty standard on most of the Eggtimer builds, so they're recognizable. But it's a 4-pin package. Now this one's pretty interesting. It's a MOSFET. You don't see these too many of these on the builds, but this is what the MOSFET looks like with 3 total pins. You get a couple LEDs. You got a red LED and an amber LED. This is what they look like. And now we're going to go through the resistors. You've got a 1K resistor marked 102. You get 2 of them. You need 1. Chris always provides an extra one in the package for most of the resistors, just in case you lose one. You get some 2.2K resistors marked 222. You need 2 of these. You're going to get 3 in your package. Then you have some 10K resistors marked 103. You need 3 of these, and you're going to get 4. And then finally, you've got a 22K resistor marked 223. You need 1 of these, and you're going to get 2 in the package. Next up, we have some capacitors. This is a 0.1 UF capacitor. You need 1 of these. You get 2. And this is what he means by a paper carrier. So on your checklist, when you see paper carrier, that's what they mean. This is a 1 UF. You only get 1 of these now, and this is in the plastic carrier, and it's marked with a black stripe. And then you also get a 4.7 UF capacitor that's in a plastic carrier with a green stripe. Now, these capacitors all look very similar. The 1 UF and the 4.7 UF are a little bit bigger, so that's one way to tell them apart. But once you take them out of the package, they're very hard to tell. You get some through-hole resistors here that are only used for the Wi-Fi module. You get a 3-pin header and a coil of soldering wire that I highly recommend you use if you don't have your own similar high-quality wire. I like to use a pan of ice in my builds. It's very helpful for most hobby use, but it's really helpful for when you're soldering PCBs, especially these small ones. They're hard to attached to your work surface. A couple tweezers, a flat set and a pointy set. And the first component we're going to be soldering to the board is the 3.3 volt voltage regulator, and you can see it there just below the pad. And the first thing you want to do is tin the large pad. Get a decent amount of solder on there, keep it hot, and then move your voltage regulator into place. You need to make sure that all four tabs are lined up properly on the board and centered. Now, then you're going to go through and solder each one of the smaller pins. Now, you have to wait 30 seconds at least between each pin in order to not overheat the chip, but I'm going to cut all that out so you don't have to wait 30 seconds in between each one. But you definitely need to do that. Make sure you wait 30 seconds. So in order to solder these pins in, you just heat up the pin, apply your solder, and make sure that it gets underneath the pin a little bit, and then gets a nice little tent over it, and it's nice and shiny so you don't get a cold solder. Once you get all three of those in, wait another 30 seconds, then heat up that large tab on the other side and get yourself a decent amount of solder over it, which can also act as a heat sink when you do it. Now, right there, I feel like that was a little bit of a cold solder, so I just added a little heat, put a little more solder, and there we go. It looks nice and shiny. So next up, we've got one of these 2.2K resistors. Now, you can see how small this is, and they're really tough to get a handle on it. They're slippery. So tin one pad, move it into place, and you can. I left this exactly as it was when I tried to put it on. I didn't edit this because you can see how hard it is to line up this very small part. But once you've got it lined up and tacked in, go ahead and solder the other pad and make sure you get it just slightly underneath. You don't want to over solder here. Don't bridge it underneath. These are really small again, so be careful about bridging. The next component up that you're going to put on is a red LED, and it goes in that spot right next to the resistor we just put on. So you can see here that the LED is it's got a green dot on one side, and if you flip it over, it's got an arrow, and that arrow needs to be pointing in the direction of the diode marking on the board. So right there, the arrow needs to be pointing towards that, and it goes on just like the resistor we just put on. So you just tin one side, you move the LED into place, and then you're gonna tack it in that way, and then solder the other side. It's a little bit flatter, so you gotta be careful. Don't get the solder all over the LED itself. You just want to get it to the edge of the LED, get it straight, and then tack in, and then solder on the other side. Same principles here. Don't bridge, but also don't use a huge amount of solder. You just want enough to get it covered on the edge. So there you go. Next up is another resistor. We've got another 2.2K resistor right there. You can see it in the middle of the board. So all you need to do is we'll do this one in real time. The rest of them will start speeding up because they're all the same, but you can see they're really small. So and they have a tendency to stick to your get static on them. They're hard to move into place. So just practice a little bit with these small resistors, and then get that one tacked in place, turn your board, and solder it in securely. The next component up is the other LED, and this one goes on just exactly like the red one. There's a green arrow, and the two dots point those in the right direction on the markings on the board. Tin one pad, tack your LED in, and then you are going to solder the other side in securely, and you are done with the LEDs at that point. And the next thing up is another resistor. We've got a 1K resistor here. I'm going to speed up the video here a little bit on all these resistors now. You've seen a couple go in. I think you've got the idea. Tin one pad, tack it in, and then solder it in securely. Now, we've got this rather large MOSFET that has to go into the middle of the board here. So much like the voltage regulator, we're going to tin the large pad, tack the whole component in place, and then solder all the pins in the large flat area securely. So I put a pretty decent amount of solder on the flat pad. That way it kind of acts as a heat sink, gets it nice and securely soldered onto the pad, and then move your component into place, make sure it's square, and then let that cool for a second to tack in place. Once that's done, just like the voltage regulator, go ahead and solder the two smaller pins in. You don't have to wait 30 seconds in between each pin on this one, but go ahead, make sure you get a decent amount of solder underneath the pin and a nice little tent over it, and then go back and similarly to the voltage regulator, heat up that large pad and get a nice chunk of solder tent on top of the large tab there. With that done, you've got some more resistors. Now we've got some 10K resistors right next to that MOSFET. Once again, going to speed it up here. This is a really tight little area. It's hard to get these in. They're small, and it's hard to get your tweezers in there. So, there's if I'm doing this board again, I will probably put those in first just to make it a little easier for me to get them in place. But they're not too bad. But I think personally that it would be easier to put those on when the MOSFET's not there. Now we've got some capacitors. First up are the 0.1 UF capacitors, and this is the paper carrier. Make sure you get them right. It goes right there above the MOSFET, but you got to ensure you're using the right capacitors here. There's a 0.1 UF. It's the paper carrier. And once you've ensured you've got the right capacitor, it's put in just like the resistors. You tack it into one pad and solder it securely. But it is really important on these capacitors that you make sure you've got the right ones. Okay, a couple more resistors down there at the bottom of the board near the other side of the MOSFET. You've got another 1K. I apologize. You've got a 22K and a 10K. So get those tacked in the proper spot and then solder them securely. All right. With those resistors in place, you've got another capacitor in the back. This is the 1 UF capacitor. Once again, make sure you've got the right one. This is the clear packaging with the black marking on the back, the black Sharpie marking on the back of the clear package. So make sure you've got the correct one, and then solder that into place on the spot marked 1 UF. Now you've got a 4.7 UF, and this one has a clear package with a green Sharpie marking on the back. Sure you have the right one, tack it into place, and solder it securely. For the Wi-Fi module, I like to use the silicon mat. You're going to take the module and the through-hole resistors that come with the kit, and functionally you're going to put the resistor wires in the holes and solder them in as pins. So just lay it out, and then what I like to do is then tape the module right to the silicon mat that I use. And this is a silicon mat that's specifically designed for soldering. I'll put a link down in the description here. And the nice thing about using this mat is you can just put the wire right into the mat. It's kind of self-healing when you pull it back out, but it sticks there nicely and it holds it in place vertically while you're trying to solder it. So I stick the first pin in through the hole and into the mat, and then I do the opposite corner with another resistor wire and solder that one in. Now functionally your Wi-Fi module is stuck to the mat. It's not going to go anywhere. You could take the tape off if you wanted to. And then just use your clippers to trim the wires about halfway down from the resistor itself, because you're going to need to do this all the way around all of the holes. So from here on out, I'll do one more in kind of real time, but just go to each successive hole, push the wire through the hole into the mat, solder it in place, and then trim it. And then we'll speed up the video here because it's pretty much the same all the way around now. But each time you do this, you want to cut the wire off about halfway, give or take, to the up to the resistor itself. It's really, you've got plenty of wire here. At the end, when you go to actually put this on the board, you'll find that the long wires themselves, you've got plenty to deal with. So it's not imperative that you get it exactly halfway or the same. We'll even everything out and straighten out the wires afterwards. But for now, just go around and put each wire in each hole, solder them in. You don't need a lot of solder either. At this point, you're just basically tacking in the wire. Later on, we will solder up the top of the Wi-Fi module a little bit more to make sure you have a good connection. Right now, you're just trying to get the wire to stay in place vertically. And so as you get to the end here, you're going to get to the last couple wires in. Then you're going to take the tape off and pry the module out from the mat itself. And then I find that the easiest way to straighten everything out is to take just your flat tweezers and kind of align everything perpendicular to the module itself. So kind of do it lengthwise along the module, and then go back and look at each individual pin, and you'll see that it looks pretty ugly at the beginning, but within a minute or so you can align everything properly and have fairly straight pins. And then once you get them all aligned, relatively speaking, we'll make sure we'll kind of get them in place when we go to put them onto the board itself. But then take your clippers and then just even everything out. You don't have to, once again, it doesn't have to be perfect at this point. The main intent is to just make it easier to get it into the mounting holes on the board. Do be careful when you do this. I like to put my finger over the ends of the wires because it does have a tendency to spit out little chunks of wire there that can get all over the place or get in your eyes. So just be careful when you're trimming off the ends of these wires, and control the pieces that are flying off. And that's so that at this portion, that's it. Just once again, take a look at the wires. Make sure they're straight. Don't worry about the top right now because that's pretty irrelevant at this point. We'll trim all of those off later on. Okay, now that you got the pins all in and neatened up, we're going to have to fit it onto the board itself. It goes into that silk screened rectangle on the board, and make sure you've got it oriented properly. It's inside that rectangle. And just line the pins up to the hole. I find it easier to just move each pin individually with a pair of tweezers until it fits nicely like that. There should be about 32nd or 16th of an inch between the board and the Wi-Fi module. Make sure it's not flat right down to the board, or else it could create bridges and cause some other issues. Sometimes I like to put a little piece of cardstock in there if it's going all the way down. So tape it into place so it doesn't move, and then you're going to solder each pin on the bottom of the board securely. You don't need a huge amount of solder here, but you want a nice little tent around each pin, and it should kind of seat down into that hole. If it's sitting up on top of the hole in a bubble, or you have a cold solder, make sure you go heat that back up and get it nice and seated into the hole, and with a nice tent around the pin. Some of these do carry a fair bit of current, so you want to make sure you've got a good connection here. Before we go and trim all the wires or all the pins, I like to go back up to the top of the board Wi-Fi module and make sure that each one of these pins are also soldered in securely. You can see that, like the first one I'm soldering right there, there's almost no solder on top. And you need to have a good connection with these pins to the Wi-Fi module. I've had that as a failure mode in previous builds and had a hard time figuring out what was going wrong until I realized I hadn't soldered them all the pins on securely to the top of the Wi-Fi module. Once I feel everything is soldered properly on the Wi-Fi module above and below the board, go ahead and trim all the pins off the top and the bottom. I do like to use a pair of tweezers or a pair of pliers, something to control the the end of that pin as you clip it off, because they can go flying. It can be a safety hazard. They could get under the board and short something out. So just make sure you're controlling that. I do recommend wearing iPro here while you're clipping these off, just in case something comes up. So I think you can finish the rest of those pins. We'll move on to the 3-pin header. They go into the 3 holes right next on the edge of the board there, and make sure the shorter end of the pins go into the board. I like to just put the tape right through the long pins, or the pins right through the tape rather, and tape it down to the board so it's nice and straight. Move to the other side and solder each pin securely. Put a decent bit of solder on here, because when you're going to be removing, putting on and removing connectors with a wire, so there's some stress on here. You could pull that connector out if you don't have enough solder, but not too much. Don't bridge it to the Wi-Fi module. For battery, I'm going to be using a 2S LiPo, so most of mine all have a JST connector. So I'm going to solder in a female JST connector to the board. Make sure you got the polarity right. Check it against your battery. There are batteries that have different polarities, so make sure that your connector and your batteries that you're going to be using are connected to the right terminals on this board, right? So right now I'm soldering in the negative wire, and now I'm going to do the positive wire. You'll notice I'm using a set of helping hands to hold that wire in place. Very useful when you're soldering these boards if you have a set of helping hands available. Once the battery connector is in, we are functionally done building the board. Now we're going to test it. I'm using a MissileWorks RRC3 flight computer. Notice that I also have a set of wires soldered to the battery out, and they're going to go to the battery in on the flight computer. This is how the switch, the mini switch, controls your flight computer. It just basically turns the power on or off. So there's a couple things we need to do here. One, like I said, you're gonna solder a couple wires right to the battery out connectors. Put those into the proper, in this case, terminal block connectors on this flight computer. Once again, make sure the polarity is correct. And then we need, since the power the power to the computer is going to turn it on and off, we need to bridge this computer's switch connectors. So we're just taking a little bridge wire here. You could use a piece of paper clip if it fits, or a spare piece of resistor wire, whatever you're using. And you're going to stick it into those holes for the switch terminals on the computer. Screw those in tightly, and now we should be able to power the computer on just using the mini switch. So we're going to connect the whole thing to a battery. In this case, I'm just using a 2S LiPo, and it's powered on, but now we need to connect it to Wi-Fi. So we've connected it to the Wi-Fi, and we can see that the output is currently off. Now, if we go through and we type in the arming code and hit submit, it should turn our computer on. All right, excellent. We did a good build here, and it works. So you can turn it off by doing the same thing, put in the code again and hit submit, and it will turn your computer off. This is great, so you can disarm your computer on the pad or after flight. Well, this was a good build. Everything worked out well. If you've got any questions, put them below, and good luck.